Okay, let's look at this problem from lesson 1. And this is isometric dot paper. And I want a 2 by 3 by 4. And I want the base to be the biggest. So pick a dot. I want to say any dot, but let's pick a dot here. And you have to go diagonally. Some of you went sideways. I'm going to go 1, 2, 3, 4. There are 4 spaces there. Does everybody get that? And then I'm going to do 3. 1, 2, 3. And then I'm going to do the height, which is 2. And then you can start to see this take shape. I don't like my picture, so I'm going to make it better. What?
So when it's 2 by 3 by 4, which one's height, which one's length?
They said they want it on the biggest side. So I put the biggest side on the bottom.
So you put 4 by 3?
Yes.
Too high.
Then all those are all the edges of your prism. Okay? Girls? Those are the edges of your prism. I'm trying to get it white. Okay? Now, here's the problem, Zach. Some of you need some visual models. All these edges here are congruent. Okay, Kat? These edges are congruent. So when I draw the other part of my prism, this is going to be 2, and this is going to be 4. See, it's parallel and congruent. This is going to be 2. And then I need this one off my dots a little bit. And there it is. So it's sitting on the biggest base. So some of you have the wrong dimensions. Some of you have it sitting on the wrong base. And if you want to do the hidden sides, we can. That's parallel, congruent to this. That's 2. Parallel, congruent to the height of 2. Okay? So that's not so easy.
So if you ever see like 2 by 3 by 4 and it says on the biggest space, you just choose
choose the 2 biggest numbers. At first, I did it wrong. I did 2 by 3 by 4. I did 2 by 3 in the bottom, and I realized, oh, that's not the biggest space. I didn't care. They go, well, no, that's not the directions. So I erased it, and I started again.
Yeah, I did that where I put it on.
Now, I did mine on the iPad, so it was easy to erase. Okay, that's probably the biggest question you have. You do fairly well with the 3-dimensional pictures. Now, let's open up lesson 2. And if you need my formula sheets, please take them. I have only like 40 made. But you're going to be adding up. You're going to do surface area. Some of you want to do volume. It's not volume. Okay? So if you need these sheets, it's also posted in the updates on Schoology. So you could print out your own or go look at it on Schoology. Okay, guys? So you're going to need these formulas. So everything we did in the last unit, which you guys did very well in the last unit. Yeah?
Yes. Thank you.
So feel free to take those. I don't have enough for everybody because I didn't make 2 class sets. Okay. We're going to do surface area. Okay, guys? This was a cardboard box. Okay, Matt? TJ? And it's been covered with paper here. How much paper did they use? TJ, focus, please. Okay? So what we're going to do, girls, is we are going to find the area of all the faces. So I have to define some of those things. Well, it's what I call putsy because you have to add up all the pieces. Now, you need to show me what you're multiplying and adding. Answer alone will not get you credit. Okay, here's a prism. And a prism is made up of 2 bases. And in this case, it's a rectangular prism, so it doesn't really matter what the bases are because any side could be a base. But it's 2 bases. In this case, this is a hexagon, right? 1, 2, 3, 4, 5, 6. So this is a hexagonal prism. And the bases are the two polygons that are parallel. And they're congruent. And I just want to wrap this in wrapping paper. I want to make sure I have enough paper. Okay, Matt, Emmanuel, I need you focused up here. So I want to find the area of it. Now these are the bases. This is a base. The bases are the two sides that are parallel and congruent. Okay, Zach? TJ? And then the polygons that make up the sides are called the lateral faces. So this is a lateral face. In this case, how many lateral faces are there here? 6. And this edge here is called a lateral edge. Laterus means side. Lateral pass. I know lateral pass in football means it can also go backwards, but generally speaking, it's a sideways pass. Okay? So when I paper this, I got to find the area for all the faces. I'm not filling this up. I'm not doing volume. I'm doing surface area. Okay, so when you find the surface area, and I believe these are the first 2 problems right out of your homework, you just add up the areas of all the faces. Well, this is a cube, isn't it? What's true about all the faces of a cube? Rubik's Cube, right? Okay, so you should be focused up here. And so I find the area for one face. So that's 5 times 5. And how many sides are there? Now, if you need a model, get one out if you actually have to touch it. You've got the top and the bottom, that's 2. You have the 2 sides, 2 more, and you have the front and the back. So it's a total of 6. They're all congruent. Now, okay guys, I could do 5 times 5, 25 times 6. I know 6 quarters is $1.50. Or I could make this easier for myself and multiply those together first. So 30 times 5 gives me 150, and if these are centimeters, we'll make them square centimeters. The volume would be 5 cubed, 125. We're going to do volume later. Right now, we're just going to do surface area. Okay, we will do volume in this unit, I believe. Okay, look at the next one. This one kind of looks like this, except that that's a square face. Hey, Colin, I've got this one. I have a 37 by 37. How many of those do I have? I've got the front, and I got the back. Okay, I don't have my calculator handy. So I've got 2 times 37 times 37, right, TJ? Now what about the sides? I have a 9 here and a 37 here. How many are those? I've got 9 times 37. How many of these little pieces do I have? I've got these 2 on the side, but guess what? The top and bottom is also 9 by 37 because this front face is a square. So I've got 4 of those. And you just multiply them out, and then you add them up. That's all there is. Now, the regular polygons give you probably more trouble. So you find the area of each of the faces of the figure, whatever it is, and you just add them up. I want to at least see what you're multiplying.
How did you find the area?
Because this piece right here, this length is 9. If I pull it out, this length is 9. And how tall is this? It's the same as this, which is sort of like one of the problems on the assignment, on the almost the very last page of the assignment for today. We had to find x and y. So it's a matter of visualizing that. If you need to use a model, I used to have little plastic figures. I don't know if we still have them in our department. And I'd actually write the numbers on the sides, on the edges. That helps. Okay. That is a triangular prism. Does it look three-dimensional? Looks kind of flat to me. Looks better here. Okay. What shape is the base? Careful. Bases are the 2 that are congruent. It's the triangle. It's that one and this one. So what do we have? We have 2 of those, right? So it's 2 triangles. What's the formula for a triangle? 1/2 base times height. What's going to happen to the 1/2? No, there's no distributive property because distributive property is multiplication over addition. There's no addition. These just cancel out. I can multiply those. I could take half the base and then double it. Seems like kind of silly. What's the base of my triangle? I'm going to pull it out. Here's my triangle. The square connects the base and the height. How big is this leg? This is 3, and this is 4. So that's these two segments right here. It will be. And how long is this segment? It's the same as that one. And when we learn about right triangles, we'll know how to get that. It's a special family. That's 5. Is that okay? Yes? You see why that's 5? This is congruent to this. Okay, so it's 1/2 base times height. The halves go. The base is 4. The height is 3. So the area of the triangles is 12. Area of 2 triangles. Now, what else do we have left? We have rectangles. I have 3 rectangles, all with the same height. So I have this rectangle, which is what? Area of the rectangle is base times height. So it's 5 times, how tall is it? 10. Let's do the green one. That's this one right here. This is how long? That's 4, and the height is 10. That's 4 times 10. And let's do a purple one for the back one. Let's see if I can find it. It's right here. Do you see it? You see this back rectangle? This is 3, because it's the same as that, times 10. And then what do you do with all these numbers? Add them up. So this is going to be 12 plus 50 plus 40 plus 30. 132, is that right? Centimeters squared. Because it's how many squares make up that space. You're wallpapering the prism. If you think of the nets that were on the worksheet, you could make a net out of that. It would be 2 triangles and 2 rectangles. I have a hard time doing that. Okay, now is when it gets a little tougher. 2 more problems, that's it. This is a hexagonal prism. It's a prism because these are going to be hexagons. And they're 2 parallel bases. So should we do the hard part first, the hexagons? It's a regular polygon. Do you remember the formula? If you don't, I got those yellow sheets. Some people have taken them already, which is good. It's 1/2 AP. Do you remember that? How many of these do we have?
2.
So I have 2 times 1/2 AP. Now, the 2's are going to cancel, which is nice. What's the apothem? What's A? It says right up there. 6.05. The perimeter, at least that's been the history that I can remember teaching this years ago, was that everybody forgets to multiply by how many sides there are. How big is the side? The side is 7, but how many sides are there? So I have to have 6 times 7. P is equal to the number of sides times the length of the side. Okay, TJ? Okay, I don't know what that is. It's 42 times 6.05. Ask me if I care. Okay. 42 times 6. 6 times 7 is 42, 6.05 times 42. Estimating, that's 40 times 6. 240 something. But there's 2 of them. But there's 2 of them. Well, I canceled the 1/2s. 254? I knew it had to be 200 something. 254 point what? Okay. That's the hexagons. New color. What's true about all of these little rectangles? It's a regular hexagon. Their sides are all 7. Their heights are all whatever the height is. What's the height? Okay, so this length is 20. So the area for the rectangle is base times height. How many are there? How many rectangles going around this thing? Is the hexagon 6? So it's 6, the base is 7, and the height is 20. So it's 42 times 20, or 840. And what are you going to do with these numbers? Add them up. You want a number there, don't you? Let's see, 4, 9, 1094.1 square centimeters. I don't like adding sideways. Is that right? Nobody's going to check me? You just trust me? Don't trust me. I make mistakes. Okay, any problems with that? That's the outside. Truck's backing up. Okay, one more problem, and these are for pyramids. Pyramids are now made up of not rectangles, but what are they made up of?
Triangles.
Triangles. I forgot to bring my pyramid pictures in. Okay, so I want the area of my pyramid. So you have the area of the base. There's only one base. Plus the area of the triangles. Okay, so let's find the base first. TJ, how am I going to find the area of the base?
Oh, use the actual side.
No, there's only one base. The area of the base is 1/2 AP.
Yeah, I know. I was trying to think if I thought I could.
There's still only one base. What's the apothem here in this problem?
Yeah, but you need to sign it.
1.68. And the side, they told me, was 5. And there are 5 sides. And I don't know what that is, but that's what the base is. So half of 1.68 is 0.84 times 25. 210? Am I right?
Yep.
Is it 210? You don't want to know how I did it? Yeah, but you've got, oh yeah, it's going to be 21. Sorry, off by a decimal. That's 21. Because that's about if I think of it as 0.25, it's a fourth. Fourth of that is 21. But it wasn't the fourth, so I had to move the decimal back, but I moved it back too far. Okay. Not a math trick, just knowing my arithmetic, that's all. Okay, now, I have what still do I have to add up? No. What shape is left? The triangle. Okay, I'm going to bring up a better picture than this, but I want the area of the triangle, and it has a height of its own. Its height is not the height of the pyramid. The height of the pyramid goes to the center of the base. The height of the triangle is actually on the side. It's called a slant height. It's L. Okay, if you guys don't get this, you're going to wonder what L is. So I'm going to bring up a better picture. Take me a second, maybe. Oh, no. Oh, no, I don't want that. Shapes. It takes me a second to get down to them. Cubes. Look at all these nice little pictures I got here. There it is. That's a nicer picture. Okay, you guys? The slant height is the height of the triangle, which is on the side of the pyramid. Okay, TJ? Do you see what the slant height is? The height of the pyramid goes here. And that's the perpendicular. And eventually, we will use right triangles to find the slant height. At least I think we'll do that. We have in the past. Okay, but we don't know anything about right triangles at the moment, so we can't do that. But I know that it's 1/2 base times height. So it's 1/2. It's the base times the slant height. The base was 5, but this height right here that's actually on the triangle, which is at an angle, That's why it's called the slant height, was how big? 11. So it's 55 halves. And how many of these do I have? I have 5. So 5 times 55 halves, whatever it is, 137 point what? 5? So I'm going to add that plus my 21. And there we go, square centimeters. Zach. Okay, any questions on that? You have to look at the shape and add up the faces. You have the little orange sheet, so now you have the formulas in front of you. The hardest part, I think, is going to be the regular polygons because you're not as familiar with those. And just add them up. Find the area of each face. Think of wrapping it up with paper. You want to paper each one of those triangles. And if I pull that triangle out, this height here is the 11, and this is the 5. 1 minute.